Hi, I'm Jess and welcome to Street Science TV as we explore some of the awesome concepts behind heat. Now, these lessons I want to teach you in a few series is actually a request I had from a teacher out in school. Hi Mrs. Bell, nice to see you again. Whenever you do see us out and about in school or in the community and you do have any science questions, please do ask us or email them, send them through in our socials so that we can make a Street Science TV episode especially for you. Now, heat is our concept today, and I want to start with the fundamental idea that heat is actually a type of energy. Did you know that? Yeah, I know, crazy, right? Heat is something we deal with every single day, but to think about it as a type of energy is a little bit abstract. So let's start with a type of energy I know you'll understand. Lollies, sugar. Yes, we as living things need nutrition like the sugars in this lollipop to help us survive, to give us energy to move and groove. And sure enough, if I were to eat one of these delicious lollipops, I would feel like I have energy. Energy is the ability of something to do work. Right now, that energy is stored inside this lollipop as chemical energy. But if I were to unwrap it and eat it, well, those chemicals, those sugars would make their way down to my stomach. Inside my stomach, my metabolism would rip those chemicals apart, and the energy that was locked inside those sugars would then be pulsing through my body, allowing my muscles to move, my proteins to do work. Now, you've all experienced a bit of a sugar boost before, and you know that having one lollipop would give you a little bit of energy. But imagine if you got to eat a whole bowl of lollipops, right? You would have so much energy. Well, I know I'd go a little bit crazy. I'd be running out of our studio, down the street, trying to burn some of it off. Heat kind of works the same way. Heat is a type of energy. It can be given to something, like me taking a lolly, or interestingly, be taken away as well. And when that energy moves into a substance, it gives the particles of that substance energy, just like me, to move. Here at Street Science, we often simplify heat to say that heat is movement. Movement of particles, the tiny, tiny building blocks that make up everything around us. Like this water. I have 2 cups of water in front of me. That water is made of teeny tiny little particles of H2O. Each of those H2O molecules is moving around, sliding, gliding over the ones around it. As a liquid, they stay taking the shape of this container, but they are moving. They have a bit of heat. One of these cups actually has far more heat than the other. Now, you might be looking at these cups. You might see there are some differences in their appearance. And from those differences, you might be making some assumptions over which cup has more heat energy already. But I'm going to give you some more evidence. I'm going to add some drops of food dye into these 2 cups of water. The one with more heat energy will have those particles moving more, which therefore means that that food dye will, well, I'll let you guys see for yourselves. Let's explore how heat is the movement of particles as we add some food dye to one, then the other, and watch what happens. Are we seeing a difference? I know I am. From what I can see right here, from my point of view, I can see a huge difference in the way that food dye is moving, dispersing through those liquids. One appears to be mixing really, really well, suggesting that those particles of water are moving a whole lot more. If they're moving more, they have more energy, not from lollipops, but from heat. If they're moving less, well, that suggests they have less energy, and we can say that it has less heat or is a colder solution. Have you made your assessment? Yes, totally. Our red solution here is almost entirely mixed up now because those little particles of our hot water have far more heat energy. Whereas our beautiful blue shape has only really dropped to the bottom of my cup. instead of dispersing through, because the cold water in this cup doesn't have anywhere near as much heat energy. Those particles aren't moving nearly as much because, well, they have less heat. Now, understanding that heat is the movement of particles is just the beginning. There are so many other concepts we can explore. So check out Street Science TV if you'd like some lessons on, well, how heat is transferred or any other questions you'd like us to answer. I'm Jess. I'll see you soon.